All right, number 8. 1,200 kilogram car traveling with a speed 29 meters per second. So this is the mass in kilogram, 1,200. And then this is velocity, so you can calculate kinetic energy. And then it drives horizontally off a 90-meter cliff. Okay? So this is the height. Okay. Well, the question is not asking you about kinetic energy, but only potential energy. Yes? Oh, good, baby. Okay, potential energy. So all you need to do is write out your potential energy equation, P equal mgh, right? And then your m is 12 kilogram times your gravity is 10 times your h is 90. And use your calculator, and you will get 108. Okay, so your answer is D. Question number 9. Sorry, my baby is very needy. Question number 9. The mass is 2 grams. All right. Next question, I also explained this question in previous video. It says the masses of 2 grams of 8 grams are moving with equal kinetic energy. Look. Very good. Okay, the mass is 2 grams and 8 grams, okay, are moving with equal kinetic energy. So that means half mv squared, which is the first mass, should equal to the half m2 v2 squared. Okay, so in regularly you have to very good. Regularly you have to convert gram to kilogram. But here we both on both sides we have grams, so it's okay if we're just looking at the ratio. So we have originally you have half and half canceled out, right? So you have 2. It's the mass 2 v squared. V squared should equivalent to 8 v squared, right? So in order to calculate the momentum of them, we have to find the v because momentum is mv. So we know 2 and 8 we can simplify as v1 squared equal to 4v2 squared. So that means you square root both sides. Okay, v1 is equal to 2v2. All right, and then so that means divide by 2. So v1 divided by 2 is actually v2. All right, now you plug in the ratio of momentum. So momentum is mv, right? So your first m is 2 grams times v1. Okay. Okay, and the second one is mv, which is 8 times v2, but it's also equal to 8 times v1 divided by 2, which is 4v1. The first one is 2v1, the second one is 4v1, so your answer, the ratio is 2 or 4, so it should be half. Okay? So the answer is half. Okay? All right. Next question. What kind of energy are included in the term mechanical energy? Mechanical energy definition is potential and kinetic. Okay. So the answer is this. Number 11. Superman can throw 25 kilogram rock with a velocity of 100 meters per second. M1, B1. 30,000 kilogram asteroid, so M2, is falling to Earth with a velocity of 5 meters per second, so V2. How many rocks must be Superman throw at the asteroid in order to bring it to a stop? So how much energy or momentum, how much momentum that the asteroid is going towards the Earth is how much Superman, the momentum of Superman, have to put in there, right? So the momentum of the asteroid is mv, which is 30,000 times 5, which is 150,000, right?
Mama,
and then
Mama,
the momentum of Superman can throw one rock.
Mama.
So each rock he threw is still mv,
Mama,
which is
Mama,
2,500, right? And then you use the momentum of the asteroid divide by the rock, which is 60. Okay. So the answer is okay, number 12. An automatic shotgun has a mass of 10 kilogram. It fires 30-gram bullet at the rate of 6 bullets per second with a speed of 400 meters per second. What force must be applied to the gun to keep it in position? All right, the force to keep this in place, basically, the gun has no momentum, right? But it's the bullet that will have a back kick. And then, according to Newton's third law, you have to apply equivalent amount of force to keep the gun in place. So the force that caused the backfly, I don't know the word, is by the bullet. So the momentum of the bullet is mv, right? However, the mass must be in kilograms. So you have to convert a gram in kilogram first. Basically, you just divide 30 by 1,000. So it's 0.03 kilogram. And then, so 0.03 times velocity is 400. But how many bullets we have? 6. So your answer is 72. Okay. Number 13. The linear momentum of a car of a mass, that's moving at a speed, which is v, all you have to do is multiply. So the answer is 2,0,0,0,0. That's pretty straightforward. Okay. Number 14. A 5-kilogram firecracker explodes into 2 parts. One part has a mass of 3 kilograms that moves 25 meters per second towards the west, and the other part has a mass of 2 kilograms. What is the velocity of the second part as a result of the explosion? It's pretty straightforward. Imagine you have a firecracker. This is 3 kilograms. This is 2 kilograms. If you ever played firecracker before, you know when it explodes, one part, if it go to the west, and then the other part should go opposite direction. And then, due to Newton's law, we know that conservation of momentum as well. we know the momentum of this part will be equivalent to the momentum of this part, right? So the momentum of the first part is 3 times 25. Should be equal to the momentum of the second part, 2 times the velocity you're looking for. Okay, so that's 75 equal 2 times the velocity that we're looking for, and v equal 37.5. And reason why it must be d, it's negative because, as you see, if this is positive 25 in the opposite direction should be a negative, right? Velocity is a vector. So the answer is D. Okay. Number 5. If a ball is moving at 4 meters per second and has a momentum of 48 kilogram times meter per second, so then the mass of the ball is 12 kilogram. Well, momentum is m times v, right? So if 4 times 12 is 48, it's correct. So it's true. Number 16. Calculate the magnitude of impulse applied to a 0.5 kilogram cart to change its velocity from 1.5 meter per second east to 1.5 meter per second west. Okay, remember our impulse is equal to m times delta v, right?
Mama.
0.5. Our delta v is 1.5 minus negative 1.5. Because if you count due east, it's positive. And then due west, it should be negative, right? Change in velocity is final velocity subtract initial velocity. So it will be 0.5 times 3. That will be 1.5. So the answer is D. Number 17. A ball of mass 50 grams falls from the height of 100 centimeter and rebounds to a height of 50 centimeter. Calculate the impulse. All right. Number 18. A hammer weighing 1 kilogram moving with a speed of 20 meters per second struck the head of nail, driving it 10 centimeters into the wall, neglecting the mass of nail. Calculate the impulse. So we have Ft equal m delta v. So it's a concept, more like a concept question. So here, since we have the velocity, right? So we also have the mass of the hammer. That's not because the mass of the nail is neglected. So the only mass we have is 1 kilogram. And then delta v is final velocity minus initial velocity. And initial velocity, final velocity when the hammer pushed the nail into the wall, it stopped, right? So overall, it will come to a stopping point at rest. So 0 minus the initial speed is 20 times 1 kilogram, and you will get negative 20 ns. Okay. Next question. Inertia of a body is directly dependence on inertia. We learned that last chapter. The bigger the mass, the greater the inertia. So it's on mass. Okay. Number 20. If 2 billiard balls each has mass of 50 grams. So 50 grams you have to convert to kilogram by dividing by 1,000, 0.05 kilogram. Moving opposite direction with a speed of 36 kilogram per hour, collide and rebound with the same velocity. Two things. One, moving in a different direction, and then the collide in the middle. And rebound with the same velocity. Rebound with the same velocity. Then the magnitude of the impulse imparted to each ball due to collision is 1 kilogram meter per second. Okay, this question, you have to pay attention to the actual question, right? So the magnitude of the impulse is m delta v, right? Imparted to each ball. I was calculating the both ball, but each ball first. So m is 0.05 kilogram. Okay, and then it says the velocity we are giving by kilogram per hour, but the standard is meter per second, right? Because here our unit is meter per second. So we have to do a conversion table. 36 kilometer per hour. Convert the kilogram first. 1 kilogram is equivalent to 1,000. A kilometer is equivalent to 1,000 meter. So kilometer cancel. And then 1 hour, the opposite cancel, is equal to 3,600 second. So multiply the top, divide by the bottom, you get 10 meter per second. Okay? So 10 meter per second is before the collision. But after collision, it rebound with the same velocity but different direction. So this is V initial. V final should be the same velocity, 10 meter per second, but it should be a negative direction, so it's negative. And when you calculate the delta V is 10 meter minus negative 10. Okay? 10 meter minus negative 10, which is plus 10. So you will get 1 kilogram meter per second. So this is true, right?